Okay, so as I had mentioned in the previous video, I told you that there was going to be a couple videos coming up. The first one, I would show you how to factor a trinomial using the perfect square trinomial patterns. And then I also said that we would look at how to solve an equation using that pattern as well. So we will do that. This first video is going to go over the factoring piece. The next video will go over solving equations. Now, what I want to say here is that, you know, you don't necessarily have to use the perfect square trinomial pattern to factor, problems like 1, 2, or 3. All right, you're going to be able to factor these using the area model if you want to. But if you recognize the pattern, like I said, it's going to make the factoring process much more efficient. So let me demonstrate how this works. So if you look back in your notes, um, the two patterns that you see are, oops, I don't know why they did that. A squared plus 2ab plus b squared equals a plus b squared. Or you also have a squared minus 2ab plus b squared equals a minus b, that whole entire quantity squared. So really what we need to be able to do is recognize, okay, is the trinomial that we're given, or does the trinomial that we're given follow either one of these patterns? So let's see how to do that. Well, clearly this first one, if it's going to follow one of the patterns, it's going to be this one right here because all of the signs here are positive. All right, so let's see if it follows that pattern. So here's how we do this. The first thing I always look at are the quadratic term and the constant term. And I want to see if those are perfect squares first, because if those aren't perfect squares, then this isn't going to work out nicely. So 1x squared. So this would be my a term. So what I'm going to do is I'm going to say a squared equals x squared. So what I'm going to do is take the square root of both sides, and that means that a is equal to x because x squared is a perfect square. The next thing I'm going to do is check the constant term. So in this case, if it's a perfect square, then b squared would equal 9. And if we take the square root of both sides there, we get b equals 3. So x squared is a perfect square. 9 is a perfect square, which means it meets the first two conditions of this perfect square trinomial pattern. And that is the first term's a perfect square because that's a squared, and the last term's a perfect square because that's b squared. Now what we need to do is we need to see, now that we've determined what a and b are equal to, we need to see if the middle term is 2 times ab. So here's the middle term in question, 6x. And the question is, does that equal 2ab? Well, let's check it out. The 2 is just going to remain. Now a is equal to x and b is equal to 3. And if we simplify that, we get 6x. So this is a perfect square trinomial because the first term is a perfect square, the quadratic term is a perfect square, the constant term is a perfect square, and the middle term is equal to 2 times the product of x and 3 in this case. So what that tells us is that x squared plus 6x plus 9 is going to equal the quantity. All right, so in this case, a was x. Oops, sorry about that. Plus b is 3, all squared. So again, if you recognize that pattern right off the bat without doing all the work that I just did, so if you can kind of do that work in your head, then factoring a perfect square trinomial can be really quick, really efficient. Let's do a second one. I'm going to do this a little bit quicker. So I'm going to look at the first term. Is that a perfect square? So let's see, a squared equals x squared, which means that a would equal x. So that is a perfect square. Look at the constant term, b squared equals 25, which means that b would have to equal 5. So the constant term is a perfect square. Now, in this case, I'm not really worried about the sign just yet. I'm just looking at this kind of the absolute value of that middle term. It's 10x. So the question is, does 10x equal 2ab. And if we look, a and b, or a times b is 5x times 2 would be 10x. So yes, that does equal 10x. So that checks out. So this is a perfect square trinomial. Now this one in particular, this perfect square trinomial, follows the second pattern. So this one's going to factor to a. So in this case, a is x minus b, which is 5, all squared. So there we go. Last one. Now, one thing that you always want to do, and we've talked about this a bunch of times, I don't know why this keeps doing this. Let me grab a different pen. Is that when you look at a polynomial, anytime that you're factoring a polynomial, you want to make sure that you factor out any greatest common factors. So in this case, I'm going to check all the terms. You have a negative 3x squared, 36x, and negative 108. So it looks like you can factor out a negative 3. So I'm going to do that right now. So I'm going to take out a negative 3. Negative 3x squared divided by negative 3 is x squared. 36x divided by negative 3 is negative 12x. And then negative 108 divided by negative 3 is positive 36. So now what we'll do is we'll focus our attention on what's inside the parentheses. So we're just going to focus on factoring this trinomial that's inside of the parentheses, and we'll see if that's a perfect square trinomial. So again, is the first term a perfect square? Yeah, a squared equals x squared, which means a is equal to x if we took the square root of both sides. B squared, that last term, equals 36. If you take the square root of both sides of that, we get b equals 6. And then does the middle term, and again, we're just kind of thinking absolute value in this case, does the middle term equal 2 times BA? Well, let's see, 12x. That equals 2 times BA, so times 6 times x, which is 12x. So yes. So again, this does factor as a perfect square trinomial. So negative 3 times the quantity x squared minus 12x plus 36. That's going to factor to our GCF times, in this case, it's a equals x minus b, which equals 6, that whole quantity squared. All right, so as I mentioned before, a couple times now, if you don't recognize the perfect square trinomial pattern when you're factoring, it's not the end of the world. You can use the X box or the area model. But recognizing perfect square trinomials is going to be helpful in the next couple units when we start studying completing the square and when we derive and use the quadratic formula. So it is kind of an important idea to recognize. All right, so I hope this video was helpful. In the next one, we're going to learn how to use this idea to solve equations. So if you have any questions or concerns, feel free to email me or contact me through Google Classroom. Thanks. See you in the next one.